Hi, students. This is Dr. Campbell back with you. We are here to get into our very first video lecture of the semester. We're talking about Native Americans and how the Paleo Americans settled North and South America, and also when the Spanish explorers and conquistadors came over and encountered the Native Americans, why they had so many advantages and why ultimately they were so successful in killing off the Native Americans in what is surely one of humanity's greatest tragedies. So, the first question I want to get into in this video lecture is, how do we know where the Native Americans came from, and how do we know how long ago it was? You can rely on lecture and the textbook to answer those questions in depth, but I want to briefly go over radiocarbon dating. So let's look at this question. How do we know that the Native Americans didn't come over, let's say, 500 years ago, when Columbus, right around the time Columbus sailed across the ocean? How do we know that Native Americans didn't come over from Russia, let's say, 500,000 years ago, a long, long time ago? We know this through several techniques that I go over in the lecture, but one of them I want to talk about is known as radiocarbon dating. Chances are you've probably learned about this before. How to talk about radiocarbon dating? Well, let's start by saying that you all know what carbon is. And carbon, like a lot of different elements, it has different versions of it depending on the number of protons, electrons, and neutrons that are in it. And these different versions, we call them isotopes. Okay, so carbon has a few different isotopes, and one of them is known as carbon-14. That's not the most common isotope of carbon. The most common isotope is carbon-12. And where does that number come from? I realize we're getting into a little bit of science here. Don't worry, we're not going to spend a lot of the semester on science, but you just need to know some basics here to understand radiocarbon dating. Carbon-12 is based on having 6 protons and 6 neutrons. This very rare isotope of carbon, known as carbon-14, actually has 6 protons and 8 neutrons, giving a total of 14. And I've represented in this little drawing, hopefully you can see it, that carbon-14 is in this green color. One of the things you should know about carbon-14 is that it is radioactive. And something that is radioactive decays at a constant rate over time. Now, that's going to be key to helping us understand radiocarbon dating. Carbon-14 is radioactive, it is unstable, and over time, carbon-14 turns into nitrogen-14, which is represented by this red color. And I'll come back to this in a moment. Carbon-14 is present in the atmosphere in very, very small quantities. In fact, as I'm speaking right now, I am breathing in and out as a living organism very small amounts of carbon-14. When you are sitting at home or wherever you are and you're watching this video, believe it or not, you are breathing in and out very, very, almost undetectable, very, very small amounts of carbon-14. Now, how does this relate to Native Americans? Well, to come up with the precise date of when the Native Americans came over and started populating North America, we use this radiocarbon dating. And let me sort of talk about the logic that scientists use. So I talked about that all living organisms take in and emit and put out small amounts of carbon-14. But, of course, living organisms die, and when they die, there is carbon-14 within their bodies, and since they're not taking in any more carbon-14, they're going to stop breathing, and that means that the amount of carbon-14 that is in their body, it's going to slowly decay into a nitrogen-14, right? Because it's no longer breathing, it's no longer taking in carbon-14. And we know that carbon-14 breaks down into nitrogen-14 at a fixed rate. And there's something known as a half-life. Now, what is that? To go back to this chart, a half-life is the amount of time it takes for a sample of carbon-14 atoms to decay into nitrogen-14, or at least half of the sample. So over one half-life, which we have figured out is 5,700 years, over that period, over 5,700 years, is the amount of time it takes for a sample, half of those atoms in that sample, to decay into another substance. A lot of different elements, if they're radioactive, have half-life. So if you study physics and chemistry, you probably know that there is a half-life for uranium and there's a half-life for radon gas, both of which are radioactive. So let's say you have archaeologists and they've come across a fossil site where they knew there were early Paleo-Americans, early Native Americans were around. And let's say they come across a sample that has about half carbon-14 and half nitrogen-14. Well, they can deduce from that that organism probably died 5,700 years ago. But let's say they come across another sample where only about 25% of the carbon-14 is left over. Well, then they can conclude from that, because they know the half-life, that probably that organism died 11,300, 11,400 years ago. Okay, so that's the thinking. I hope this makes sense to all of you watching this, of how carbon-14 works. And because that date is significant, actually 11,000, 12,000, 15,000 years ago is actually the amount of time, how long ago it was that some of the earliest Native Americans first came to what we call the New World. All right, I want to move on.